In the second part of the demo, we will use Qlik Compose to build a data warehouse and later, few data marts. Create a new project and create the connections to your source and target data. Create a connection to the data warehouse target, in this case Snowflake. We select our target database and schemas. We then create a connection to our source database, which previously replicated to a different database in our Snowflake warehouse environment. We can also associate it with a replicate task to provide more efficient data update. In this example, we are connecting to a single source database, but multiple databases can also be configured. We can also configure an optional source database connection. This will help us automate the data warehouse model generation by importing database metadata, such as relationships, into Qlik Compose. As each step is completed, you can see the green bar appear in each module, with a tick representing you're ready to move on to the next module. Now we can discover entities, fields and relationships from our source database. If you've configured the optional source database connection in step 1, additional metadata will be automatically brought in. We can then select the tables we would like to perform the automatic discovery on, and the model is generated. We can also manually verify which entities and relationships have been identified, and perform any changes to history types, configuration of hub or satellite tables, or build custom relationships between fields. We can also create new calculated fields using functions within the expression builder. We can then validate the model to ensure there are no problems with the structure of our data, and proceed to the next stage. You can also visually inspect the data model that has been generated by clicking the Display button. Now that our data warehouse structure and mappings have been configured, we can now generate and run the ETL required, in turn building the warehouse table and field structures, just by clicking Create. We can then see two new ETL instructions that have been displayed. The first is for the initial load, and the second is for ongoing change data capture, or updating of the data. We must click on each instruction to generate the ETL to fill our new warehouse tables. We click on Generate to create the ETL required to fill our data warehouse tables, and then run to perform the ETL on the target database, in our case Snowflake. As you can see, the progress is displayed for each ETL instruction that is performed on the target. We then perform the same process on the second ETL instruction, used for change data capture, and is run to update our warehouse with changed data from the source system. We can now create any number of data marts, either using the star schema wizard or manually. The star schema wizard is displayed, and we configure this to show us a transactional fact table, which will show us the latest data in the data warehouse, and in turn, the source. This data mart will include data from two data tables, our customers and our customer addresses. As you can see, these tables are related, as identified in the Discover feature from Step 2. Finally, we choose a transaction date from our data warehouse tables to identify the latest data. We can add additional data marts if needed, but in our case we have just the one. We then click the Create Tables button to generate, and run the ETL in our data warehouse, building the data mart table structure. After the ETL has been generated, we can then click Run to load the data from our warehouse into the data mart. We then click on the Monitor tab to see the workflow information surrounding our project. As you can see, each task is detailed, in addition to displaying us with two workflows. The first default workflow is used for the initial load, and the second default CDC workflow is used to load the latest data from the source database replication into our warehouse and data marts. We can then perform a run of our CDC workflow to bring in any new data from the source database replication into our warehouse and data marts. This process can be automatically scheduled using the scheduler function to run at set intervals. In our particular case, we're configuring an update to our data warehouse and data marts every 2 hours. You can see the progress of the workflow visually as shown in the lower pane.